Welcome to C&EN Uncovered. I'm Craig Bettenhausen. C&EN Uncovered is a production of stereochemistry. In each episode, we'll take a deeper look at a recent cover story in chemical and engineering news. C&EN's savvy chemistry reporters will share striking moments from their reporting, their biggest takeaways, and what got left on the cutting room floor. In this episode, we're diving into a cover story from January about lithium iron phosphate, a once-and-future battery material that is getting a lot of attention and investment right now. I'm here with Matt Blois, who wrote that article. Hi, Matt.
Hey, Craig.
We'll link to that article in the episode's show notes, or you can find it in the January 30th print edition of C&EN. That's January 30th, 2023. Definitely check it out if you haven't already. So, Matt, for those people that haven't had a chance to read the story yet, can you give a brief recap? What is lithium iron phosphate, and why do we care?
Yeah, so lithium iron phosphate is a powder, basically, that you can use to make the cathode of batteries, and the cathode is just the positive end of the battery, and it's the most valuable part of the battery. And in North America, most of the electric cars you see on the road will use a battery that's made with nickel, but nickel can be really expensive, and especially they're usually nickel and cobalt, which can be especially expensive. So a lot of companies have been looking around for ways to decrease the cost of batteries, and lithium iron phosphate, which it's also called LFP, is a really good way to do that because it avoids nickel, it avoids cobalt, and you're instead using something like iron, which is just a lot cheaper as a metal. So the story's about a couple of different companies that are trying to set up production of the LFP powders in North America. And LFP, it's actually pretty common already in China. I think something like 40% of the cars in China have LFP batteries in them. But it basically isn't used in North America. And the reason is because people in the United States and Canada, we like to drive pretty long distances. And so the car companies have really favored these nickel batteries, which have higher energy density, which means if you're in a car, you can drive farther. So LFP is this option that your car might not go quite as far, but it's going to be quite a bit cheaper. And so a lot of car companies are sort of reevaluating that, cost versus performance trade-off there. And a lot of them don't want to rely on China to get those batteries.
One of the other things you talk about in your story is that this is getting a lot of investment. Nano One is one company, but there are several others. It seems, though, that this chemistry is proven. There are thousands of vehicles on the streets in China doing it. So I guess my question is, why are these battery makers and firms getting hundreds of millions of dollars of government subsidy and support? Because I usually think of that sort of thing as being targeted at more risky technology.
Yeah, so the basic science of it is totally there. There are two things that I see as a little bit risky with LFP in North America. So the first thing is that pretty much all of the expertise, except for this team at Nano One, which has done it at relatively small scales, but they've done it. Almost all of the expertise for doing large scale LFP manufacturing is in China or in Taiwan. And really, it's only one company that I'm thinking of in Taiwan. And so there's this question about, how do you do, the tech all went over to Asia. And I think there's a little bit of risk of how do you get that tech back to the United States? Because inventing something is not the same thing as scaling it up. Even though there are plenty of companies that have scaled it up, that doesn't necessarily mean that anybody can scale it up. I think it's just, there's where are you going to get your engineers to run your factory and that kind of thing? I think that's a big question. The second thing that I think is a little bit risky on LFP is who's going to buy it. Because there's all these car companies that say, you know what, LFP is the next big thing in North America. We're all going to use it. Ford, Tesla, VW, they all say that this is something they're going to pursue. But for the most part, I think there are some Teslas on the road in the United States right now that have LFP batteries. But for the most part, this is not, people are not buying LFP batteries in the United States or anywhere in North America yet. It doesn't exist. There's all this research about range anxiety that's really interesting. They'll look at how far does a typical American drive, and on any given day, any old battery is going to get you that far. LFP is, for 95 to 99% of the time, an LFP battery is going to absolutely accomplish everything you need. But I think there's going to be a lot of people in the United States specifically, they're going to say, well, what am I going to do about that 5 to 1%? Because we live in a country that has no pedestrian or bike infrastructure or public transportation. So if your car can't get there, you probably don't have another way to get there.
So a lot of the activity in LFP up to now has been in China. And one of the things I noticed in your story was that there was this deal where the existing patent holders for the LFP production chemistry and other parts of the technology agreed to let the Chinese firms use that technology without paying licensing fees, as long as the Chinese firms only made LFP in China. Why on earth would the LFP patent holders agree to that kind of a deal?
I don't really have a good answer to that question. It was something that puzzled me, and I think has puzzled a lot of people. This little piece of the story actually took I talked to a lot of people about this, and a lot of people I talked to were sort of unsure of the exact details of exactly how the arrangement was working and exactly why it happened in the first place. So there's not really specific answers about that.
And so this company that has basically all the people that have ever actually made LFP on this continent, what's the name of the company, the new company again?
The company we're talking about is Nano One. So they're
okay.
a Canadian startup, and then the original company was Fostech, which was the company that was started in early 2000s and scaled this up, and then Nano One bought that facility.
And so you actually went up there to Montreal. Tell us a little bit about that trip.
Yeah, so Montreal is a beautiful city. I stayed in sort of the downtown area of Montreal when I flew in there, and then you cross over the St. Lawrence River to the south, and this facility is just right across the river. So it's not really in downtown Montreal, but it's if you walk outside, you can sort of see the Montreal skyline across the river. I was pretty excited to visit this facility because of the history there, because I think it's so interesting. LFP was first invented at the University of Texas, and then it really, that idea went up to Quebec, and you had Hydro-Quebec and the University of Montreal working on this technology to improve it. And it was eventually Fostech that got a hold of the license to go for it and try and scale it up. But it was really interesting to, just from a historical perspective, to see how far they got, because it's not a small factory. I mean, compared to the Chinese factories, it's minuscule in scale. But in terms of, when you're walking around it, it's multiple levels. It's like large warehouse size. I think 4, maybe 5 different levels. Big machinery, just like pipes going everywhere. It was pretty quiet when I went there because Nano One had just bought the facility. They were really moving in and sort of getting set up. There wasn't a lot of activity going on. But it also sort of emphasized to me that the fact that this plant that felt pretty big walking around in it was, way smaller than the size of plants that still need to be built to sort of serve growing battery industries. And that's what they're trying to do. I mean, I think Nano One sees this as sort of their test facility where they're going to try things out and scale it up. And they're already planning on building a bigger one right next door. And then I think the ultimate goal is to partner with large companies to do even bigger scale manufacturing.
Your anchoring character, Denis Jeffrey, is back at the former Fostech plant that he helped start back in the day. But it's been 7 years and a couple different owners. How much of the people and institutional knowledge is still at that plant in Montreal?
There's a significant number of people who have been at that plant for, more than a decade, I think, at this point. So I think that institutional knowledge is hugely important because nobody else in North America has really done it at any large scale. And pretty much everywhere else is in Asia. The really large ones are in China, and then also you have some expertise in Taiwan too. So Denis was really the leader of that plant and has been there for a long time, but much of his team is still intact. And a lot of people I talked to said, that's really, when this startup bought the old Fostech plant, that's what they were really buying, is this institutional knowledge. Because the process that they're really completely retrofitting the facility. They're reusing a decent chunk of the equipment, but really the entire process is going to be totally new. But the way Denis described it to me was, because they set up a separate solid state facility in Canada that was smaller first. And then they went on to this bigger facility and built up an entirely different process. And now they're kind of doing it this third time. And even though it's a new process, I think Denis is saying, we're good at building LFP factories kind of no matter what the process is.
Now, the story mentioned that, trolling motors are one place you can get an LFP battery today, like for a boat, for going fishing. Where else might these things fit? Because I'm imagining e-bikes and small motorcycles. Where else is this technology a good fit?
Well, it depends on who you ask, but it certainly can work in electric vehicles. I mean, like I said earlier, this is common in China. Personal cars that don't need to go super long distances, LFP can be a really good chemistry for that. Also buses, there's a lot of buses that end up with LFP batteries. Another place that people look at it is for the energy, sort of stationary energy storage. So you're a lot less concerned about energy density when you don't have to move the battery at 60 miles an hour down the highway. If it's just sitting in your house, it can be a little bit bigger. It certainly doesn't matter how heavy it is. So things like that, stationary energy storage is definitely could be a good use there. So usually when I see sort of comparisons of different performances of battery chemistries, they'll show it on this graph where it's like a pentagon, and each point of the pentagon has sort of a different facet of batteries that you might be considering. So energy density is a really important one for cars, but you also have things like cycle life, like how many times can you charge and recharge the battery? So LFP is actually better than nickel-based batteries in terms of how many life cycles it can go through. It's also safer. It's less likely to catch on fire than nickel-based batteries. So it has some advantages in safety and cycle life, even though you're giving up a little bit on the energy density side.
So you mentioned that LFP can be cheaper than the nickel-based batteries, but nickel and cobalt are also more toxic metals. What kind of difference does it make as far as the environmental footprint?
Yeah, that's a pretty big part of why, in addition to the cost, the sort of environmental concerns and sort of social concerns that go along with that are a pretty big part of why car companies and battery makers are interested in LFP as well. So a lot of the nickel ends up coming from Indonesia, and there can be a lot of environmental problems. You end up having waste go out into the ocean, and you end up having some, I think, deforestation can also be an issue. Nickel has definitely been sort of targeted as a mineral that's maybe not so great for the environment, and people aren't so happy about how it's being mined. The issue with cobalt is actually more on the social side. I mean, it's mining certainly has an environmental impact, but there's a lot of cobalt comes from the Democratic Republic of the Congo, and there's issues where you end up with children who end up working in the mines. And when, this is the very start of a supply chain. I mean, these are people who are, I think with cobalt, it's a lot of people who are actually sort of picking up rocks and digging with shovels by hand off the surface. And it can be pretty disorganized and hard to tell exactly, trace that supply chain all the way back, especially if you're like a battery maker that's on a different continent. But there's big social concerns about having children working in cobalt mines. So car companies, don't want to be involved in that. So they're trying to either make sure that their cobalt is mined safely and by adults, or another easier way to ensure that you're avoiding all of that is just to not use cobalt. And the fact that cobalt is pretty expensive is another reason to make that decision. So yeah, there's definitely some environmental and social concerns with, especially in the nickel and cobalt.
So what else were some interesting nuances and tangents that just didn't fit into the print story, but that you found really interesting when you were, getting ready to write it?
One thing that I didn't get to write about very much that came up a little bit with different companies I was talking about is this idea of like what comes next after LFP. Because there's, if you look at sort of the development of battery chemistries, there's this trend where you're going from nickel cobalt oxide to nickel manganese cobalt to LFP. And so you're moving from these things that are like super high energy density but expensive to things that might have a little bit less energy density but they're less expensive. And you see other companies already talking about like, can we use sodium ion batteries because lithium is expensive? LFP still has lithium in it.
Yeah. So
can you use a sodium ion battery or potassium ion battery or something like that? And how do you sort of move in that direction of cheaper materials, less environmental impact, more reliable supply chains without losing too much performance?
Now, you mentioned a couple of times how active this area is from research, but especially from investment. And some more things have happened in LFP even since this story came out.
Yeah. So the big one, and this is one I mentioned sort of the rumors of this in my story when it came out in January. But this was just recently, Ford is now going to have this partnership with CATL, which is the biggest battery maker in the world, based in China. They're going to set up an LFP cell factory in Michigan. And it's a big plan. It's like $3.5 billion. Wow. And I think one of the really interesting things is we talked a little bit about, where does all the LFP expertise come from? And I think it's it's really interesting to think about how Chinese companies are going to play a role in that, and what role do they want to play? What role does the Chinese government, what does the Chinese government think about that? What does the US government think about that? Because I know when Ford and CATL announced this deal, both policymakers in the United States had a lot of questions about it, and policymakers in China had questions about it, how it was going to work. But, I think if you're a car maker and you really want to go with a company that knows what they're doing on LFP, CATL, they do a lot of this. They really know what they're doing. Obviously, that it comes with some geopolitical risks. And then another thing that I think is an unanswered question is, we just had last year the Inflation Reduction Act pass. It's supposed to subsidize a lot of these factories that are being built to make batteries. To me, it's not totally clear how Ford and CATL's plant fits into that.
Yeah.
I think we're supposed to get a little bit more guidance on that from the Treasury Department in March, but it's I don't think we'll quite know. Ford has done sort of some trick plays to try and I think see if they can qualify for the tax credits, but I definitely have seen some policymakers sort of at the congressional level that are saying we don't like what's going on here. We don't want CATL to be getting these tax credits that are supposed to go towards United States based manufacturing.
Well, Matt, this is all very interesting stuff. Thank you for taking the time to tell us all about it.
Yeah, it's super fun to talk about. It's one of my favorite stories that I've been able to report for C&EN, and I was always happy to talk about batteries.
Once again, you can find Matt's cover story about lithium iron phosphate on C&EN's website or in the January 30th, 2023 print issue of C&EN. We put a link in the show notes along with the episode credits. You can find me on social media as @CraigofWaffles.
You can find me on social media at Matt_Blois.
This has been C&EN Uncovered, a new series from C&EN Stereochemistry. Stereochemistry is the official podcast of Chemical and Engineering News. C&EN is an independent news outlet published by the American Chemical Society. Thank you for listening.